Have you ever wondered about the concept of limiting and excess reagents in chemistry? Well, let's start by understanding what reagents are. In the realm of chemistry, reagents are substances or compounds that are added to a system in order to bring about a chemical reaction or to see if a reaction occurs. They're like the key players in a football match without which the game cannot proceed. Just like how every player has a role in the game, each reagent has a specific role in a chemical reaction. They can either be reactants that are consumed in the reaction or catalysts that speed up the reaction without being consumed. But not all reagents are created equal. Some are used up completely during the reaction, while others remain in excess. This is where the concept of limiting and excess reagents comes into play. As we delve deeper into chemistry, understanding the roles of limiting and excess reagents becomes absolutely essential. So, what exactly is a limiting reagent, you ask? Let's dive right in. A limiting reagent or limiting reactant is the substance in a chemical reaction that is completely consumed when the reaction is complete. In simpler terms, it's the ingredient that runs out first, thus determining the maximum amount of product that can be formed. Think of it this way. Imagine you're making sandwiches. You have 10 slices of bread, but only 6 slices of cheese. No matter how much bread you have, you can only make 5 sandwiches because after that, you run out of cheese. In this scenario, the cheese is your limiting reagent. It's the one that limits how many sandwiches, or in chemical terms, how much of the product can be made. This concept isn't just confined to the kitchen, it's a principle that applies to various aspects of our everyday life. Let's say you're planning a road trip. You've packed enough food for 7 days, but your car's fuel tank can only last for 5 days. Here, the fuel is the limiting reagent. In the world of chemistry, the limiting reagent is a critical concept. It's the key to understanding how much product can be formed in a reaction. For instance, in the reaction of hydrogen and oxygen to form water, if you have more hydrogen than required but less oxygen, then oxygen becomes the limiting reagent. It's the one that will be completely consumed first, and it determines the maximum amount of water that can be produced. So, in essence, a limiting reagent limits the amount of product that can be formed in a chemical reaction. It's a fundamental concept that's central to understanding chemical reactions and stoichiometry. Just like in our sandwich or road trip examples, it's all about the balance of ingredients or components. Too much or too little of something can drastically affect the outcome. Remember, in every reaction there's always a limiting reagent that determines the maximum amount of product that can be formed. And that's the crux of what a limiting reagent is all about. Now that we know what a limiting reagent is, let's turn our attention to its counterpart, the excess reagent. You can think of an excess reagent like the extra cheese on a pizza. You may have enough dough and sauce to make 1 pizza, but if you have enough cheese for 3, the cheese is your excess reagent. It's there in abundance, but it doesn't limit how many pizzas you can make. In the world of chemistry, an excess reagent is the reactant that is present in a greater amount than necessary for a reaction to proceed. It's the one that you have left over after the reaction has occurred. You see examples of this in everyday life. For instance, when you light a candle, the wax melts and burns, but the wick, which is also a reactant, remains. Here, the wick is your excess reagent. So basically, an excess reagent is the substance that is not completely used up in a chemical reaction. Still confused? Don't worry, let's break it down using some chemical equations. Imagine you're trying to bake a cake. The recipe calls for 2 eggs and 1 cup of flour for each cake. If you have 4 eggs and 3 cups of flour, how many cakes can you bake? Right, you can only bake 2 cakes because you'll run out of eggs first. In this analogy, eggs are your limiting reagent and flour is your excess reagent. Now let's apply this to a chemical equation. Consider the classic reaction between hydrogen and oxygen to form water. The balanced equation is 2 molecules of hydrogen reacting with 1 molecule of oxygen to form 2 molecules of water. Let's say we have 4 molecules of hydrogen and 3 molecules of oxygen. Here, hydrogen is the excess reagent and oxygen is the limiting reagent. Why? Because after using up all the oxygen, we'll still have hydrogen left over. Another example is the reaction between nitrogen and hydrogen to form ammonia. The balanced equation tells us that one molecule of nitrogen reacts with 3 molecules of hydrogen to form 2 molecules of ammonia. If we have 5 molecules of nitrogen and 12 molecules of hydrogen, our excess reagent is hydrogen, and nitrogen is the limiting reagent. The key to identifying the limiting and excess reagents is to compare the amount of product each reagent can produce. The one that produces the least amount of product is the limiting reagent. The one that's left over is the excess reagent. Remember, in the real world, reactions don't always go to completion. They might stop before all the limiting reagent is used up due to various factors like temperature, pressure, catalysts, and so on. But for the sake of simplicity, we'll assume they do in our examples. And voila! You've just learned how to identify limiting and excess reagents in chemical equations. So, to sum up our discussion today, we've delved into the fascinating world of reagents. We've defined limiting reagents as the substances that are completely consumed in a chemical reaction. They determine the maximum amount of product that can be formed. On the other hand, we've learned about excess reagents. These are the substances that remain after the reaction has completed. Essentially, they're the leftover components. Through the lens of chemical equations, we've seen the roles these reagents play. They're not just mere participants, but they dictate the direction, the quantity, and the completion of a reaction. It's like a dance, with every element playing its part to create a harmonious result. So, what's next? It's time to put what we've learned into practice. Try identifying these reagents in different chemical equations. Challenge yourself, experiment, explore, and most importantly, enjoy the process. Remember, practice makes perfect. Keep practicing and you'll master the concept of limiting and excess reagents in no time.